Section 6.3, Simplifying Radical Expressions. Definition: the product rule for radicals. For any non-negative real number a and b and any index k, the kth root of a times the kth root of b equals the kth root of a times b. So we're multiplying and we have the same index, then we can multiply their radicand. So let's take a look at these lists of examples for example 1, where our instruction is asking us to multiply. So the first one, I have the square root of 3 and the square root of 5. So because we have square roots, we're implying an index of 2. Because they're both square roots and we're multiplying, I can multiply the inside together. So 3 times 5, you get the square root of 15. That would be our answer. For B, notice we have square roots again. So we have the square root of 5a times 2b. You can multiply 5 and 2, you get 10ab. Here we have cube roots. The cube root of 4 times 5, you get the cube root of 20. Here, we can still multiply even if they're fractions. Our fraction rules apply. So I have the square root of y over 5 times 7 over x. We multiply across. You get y times 7 is 7y. 5 times x is 5x. And for example E, this one, we don't have the same index. Here we have a radical. But if we really wanted to, we can try to force the same index. So let's think of them as rational exponents. So 5x to the 1/2 power times 3y to the 1/4 power. I can multiply by a special 1 to create a denominator of 4. So now that I now have 5x raised to the 2/4 power and 3y raised to the 1/4 power. So we can rewrite it now to have the 4th root of 5x quantity squared and the 4th root of 3y. So I have the 4th root of 25x squared and the 4th root of 3y. So that I have the 4th root of 25 times 3, 75x squared y. That took some clever thought. Factoring radical expression. For any non-negative real number a and b and any index k, the kth root of a times b equals the kth root of a times the kth root of b. Or ab raised to the 1 over k power equals a raised to the 1k power times b raised to the 1 divided by k power. So because we have an equal sign, I can use it going one way and then same for the other way. So let's think of this one. Can I take the square root of 50? No, but I know 50 is the same as 25 times 2. And can we take the square root of 25? Yes, so that we have the square root of 25 times the square root of 2. Now square root of 25 is 5, so we're left with 5 square root of 2. And that's how we can break down a radical to simplify. What about the cube root of 32? Well, I can't take the cube root of 32, but I know that 8 times 4 is 32, and I can take the cube root of 8. So that I have the cube root of 8 times the cube root of 4. The cube root of 8 is 2, so we're left with 2 cube root of 4. Fourth root of 48. Well, I can't take the fourth root of 48, but I can take the fourth root of 16, and 16 times 3 is 48. So I can write this to be the fourth root of 16 times the fourth root of 3, so that I have 2 fourth root of 3. And that's how we can break down a radical to simplify. Now let's take a look at example 3. Simplify and assume that all values are positive. I have the square root of 5x. Can we simplify that further? No, we can't, right? So we want to look for something that's raised that I can write as a square to get an answer. So that one's just as is. Now we have 18x squared times 5. All right, I know I can get 18 from 9 times 2, and 9 is a perfect square, so that I have the square root of 9 times the square root of 2, and I can separate my exponents, so I have the square root of x squared and the square root of y. The square root of 9 is 3. I have the square root of 2 still in my box. Now here, the square root and the exponent, they're mathematical opposites. They're essentially dividing. What's 2 divided by 2? You get x to the first power, and I can't do anything with the y, so it stays in the radical. Let's multiply our numbers that don't have a radical together. So I have 3x, and then I want my answers with the radical together, square root of 2y. Now for this next problem, there's ways to think about it. One way to think about it is to prime factorize. If you have a really big number and you don't know where to start, you can start by prime factorization. And then because you have a square root, you want to group all your pairs. So I have a pair here, a pair here, a pair here, a pair here, and a pair there. Your pairs are what are going to come out of the radical. So that we have a 2, a 3, and your x and your y. Everything else stays inside the radical. Another way to think about it is start breaking down things, well, your numbers at least. I think of your numbers. I know I can get 216 from 36 times 6. And if you're not too sure, you can start with 4 and work your way up. So I have the square root of 36, the square root of 6, times the square root of x to the 5th power, and the square root of y to the 3rd power. All right, the square root of 36 is 6, and I can't do anything more with the square root of 6. Now with your exponents, they're essentially dividing. 2 divided by 5, it goes into it twice, and we have a remainder of 1. Your remainder is what stays inside the radical, so that we have an x squared and 1x still locked up in the radical. For my y's, I divide it, only 1 comes out, so I have y to the 1st power square root of y. Let's rewrite it. So I have 6 squared y, and then inside the radical we're left with a 6, 1x, and 1y. Let's take a look at the next one. We have 16. The cube root of 16, a to the 17th power, b to the 11th power. Well, I can get 16 from 8 times 2, and I can take the cube root of 8. So I have the cube root of 8 times the cube root of 2, the cube root of a to the 7th, and the cube root of b to the 11th. Okay, the cube root of 8 is 2. Cube root of 2 stays within. Now what about my a's? 7 divided by 3, it goes into it twice, and we have a remainder of 1. For our b's, 11 divided by 3, it goes into it into it 3 times, and we have a remainder of 2. Don't forget to write your index of 3. It's really easy to forget. So what do we have outside the radicals? We have a 2, an a, and a b, so that we have 2a squared b cubed, and inside we're left with a 2, 1a, and a b squared. Dividing and simplifying radical expressions. Definition of the quotient rule for radicals. For any non-negative number a, any positive number b, and any index of k, the kth root of a divided by the kth root of b is equal to the kth root of a divided by b. Or a to the 1 kth power and b to the 1 divided by k power equals a divided by b, all of it raised to the 1 over k power. Meaning I can work with them separately, or I can divide them as a radical. It really is up to your own consideration which would be the best way to approach such a problem. Okay, so for this one, I can divide 80 and 5. Why don't we write them under the same radical? 80 divided by 5. Well, 80 divided by 5 is 16. The square root of 16, well, that gives us 4. Next one. Well, let's see if I can divide and see if that's helpful. So I have 5 times the third power of 32 divided by 2. 32 divided by 2 is 16. So I have 5 times the cube root of 16. I can take the cube root of 8 and get 16 from 8 times 2. So I have 5 times the cube root of 8 times the cube root of 2. So we have 5 times 2 times the cube root of 2. We get 10 cube root of 2. Next one. Let's begin by trying to divide 72 by 2. Or let's write this under one same radical. So that I have 1/2 times the square root of 72 divided by 2 xy. Okay, well 72 divided by 2 is 36. So I have 1/2 times the square root of 36 xy. The square root of 36 is 6. So I have 1/2 times 6 times the square root of xy. 6 divided by 2 is 3. So I have 3 square root of xy. Kth roots of quotients. For any non-negative number a, any positive number b at any index k, the kth root of a divided by b equals the kth root of a divided by the kth root of b, or a over b raised to the 1 kth power equals a raised to the 1 divided by k divided by b raised to the 1 divided by k. Example 5. Simplify by taking the roots of the numerator. Assume that no radicand were formed by raising negative numbers to even powers. Meaning, assume all your numbers are positive. Alright, so let's go ahead and begin. For number 5, part A, we're saying that we can split our radical so that I have the cube root of 27 divided by the cube root of 125. And we like the idea because the cube root of 27 is 3 and the cube root of 125 is 5. So that we're done with our problem. Let's take a look at B. We like this one too because we can take the square root of each one separately. Square root of 25 divided by the square root of y squared. The square root of 25 is 5. The square root of y squared, well, that's just y. C. We can apply our square root separately, so that I have the square root of 16x cubed divided by the square root of y to the fourth power. All right, the square root of 16 is 4. X cubed divided by 2. 3 divided by 2 is 1, and we have 1 still inside. Let's divide our y's. 4 divided by 2 is 2. This is our answer. D. The cube root of 27 y to the fifth power and 34x cubed. Okay, well, the cube root of 27, not 25. I can take the cube root of 27, and that gives us 3. Now for my y's, 5 divided by 3, it goes into it twice, and I have a remainder of 1. So 1 stays within the radical. Oh, 2 are left over, because it only goes into it once. Once, and I have 2. There we go. Now for 34, I can't think of a number that's a cube root. So I can get a cube root from 8. Let's see, 34 divided by 8. No, 32 works, but not 34. And 27 wouldn't work. So all I can do is take the exponent of 3, so that I have the cube root of 34, and the x is in front, because 3 divided by 3 is 1. That's it for that one. And that's it for our section. This was 6.3, Simplifying Radical Expressions. Thank you.